This video is part of an online course of Calculus 1 and I'm going to talk about operations on functions. Let f and g be two functions. There are some algebraic operations that we can apply on these two functions. The first one is f plus g. What is f plus g? F plus g is a function such that at any point x, okay, that's definition of the addition, such that at any point x we have f of x plus g of x. Okay, another operation on function is the product. The product of two functions is a function such that f dot g at any point is f of x dot product with g of x, not actually dot product in vectors, dot times basically f of x and then g of x. F over g is a function such that we define it at any point to be f of x divided by g of x. We have a very big constraint in here, is that we need to assume that g of x is not 0. If g of x is 0, basically if you put a point in there such that g of x is equal to 0, then the fraction of the two functions cannot be defined. Okay, before I go to the example, I would like to say that if we have f minus g, okay, it would be has the same definition except that instead of adding them I have subtracting them. Okay, let me go over one example. Let f of x to be square root of x and g of x to be the function that is square root of 4 minus x. Okay, let me find f plus g. Well, f plus g at any point x is equal to f of x plus g of x. We just define it like this. For example, f plus g at a point 1, it's equal to f at a point 1 plus g at a point 1. F at a point 1 is the square root of 1. G at a point 1 is 4 minus 1. And then it would be 1 plus square root of 3. That's how we define it. Okay, let's go to the product. F dot g at any point x is f of x times g of x. Yeah. Actually, I wanted to also cover the domain of them. Let me do it this way. So what is the domain of f plus g? Okay, as you see, if you're given this function, we have a constraint on the first square root and another constraint in here. The constraint in here is that inside the square root, which is just x, should be positive, and the constraint that I have in here is inside the square root, whatever that you have should be positive. And based on this one, I'm gonna bring negative x on the other side, so 4 is greater than x. Now we have these two conditions, which says that x should be greater than or equal to 0 and should be less than or equal to 4. And so the domain is basically this interval that I have in here, 0 to 4. Okay, how about the domain for f dot g, the product of these two functions? It would be the same thing, right? Because I have a constraint here and I have another constraint here. It is going to be exactly the same. So the domain here would be also 0 to 4. Okay, let's go to the fraction. if I have f over g at x, it would be f of x, which is this, over g of x, which is that one. What is the domain? Well, I have the same constraint that x should be greater than or equal to 0, okay? And I have a constraint on the bottom for the square root. 4 minus x should be positive, but since it's on the denominator, 4 minus x cannot be equal to 0, so it cannot be equal to 0. I'm gonna erase this one. So pay attention that 4 minus x cannot be equal to 0. That's why, and here instead of greater than or equal to, I just have greater than, because this one cannot be equal to 0. Now let's put it together. X is greater than 0 and it is less than 4. So the domain is the interval closed 0 and open at 4. So I cannot put 4 into this function. Okay, so this is addition, subtraction. Subtraction is also the same. F minus g is square root of x minus square root of x. Actually, not to confuse you, I'm gonna write it like this. F minus g of x would be f of x minus g of x, and domain would be exactly the same thing. Okay. So addition, subtraction, product, and a fraction. There is also another interesting one that is called composition of two functions. So I'm gonna talk about composition. We show it by FOG, and it's a function. It's a function such that FOG at any point x is equal to f at g of x. Okay, so let me talk a little bit about the domain. Let me move this one a little bit. You see how it works is that if I have any x, okay, any point x, I'm gonna bring it to g. I'm gonna use g, the function g, and it's going to g of x, and then the function f is gonna act on g of x, and then it's gonna give me f of g of x. Look at one example. Let f of x to be square root of x and g of x to be x squared minus 9. Okay, what is FOG? FOG at any point x is equal to f of g of x. Okay, so what is g of x? G of x has this formula, x squared minus 9. So I need to find f of x squared minus 9. Now look at my function f. At any x that I see in here, I'm gonna put x squared minus 9. Okay, so x squared minus 9. That's the answer for FOG. What is the domain? Well, the domain of this function, you can explain it by this graph, basically by definition, or you can find the function exactly what we did in here and then find the domain of this function, which would be easier. Let me explain it in here first. So the domain is what? The domain is all x in the domain of g, you see, because x should be in the domain of g such that the graph g acts on it. So all x in the domain of G, it's 1, such that, let me have more space, such that what? Such that G of x is in the domain of F. That's the second criteria. So G of x should be in the domain of F such that F can act on it. You see? It's a little complicated using this definition of the domain to find the domain of FOG, but if you understand it, it is really intuitive, because FOG has this definition. First, you're gonna put x into G, so x should be in the domain of G such that G can act on it. First, we put x into the domain of G, and then G of x should be in the domain of F such that F can act on it. And the domain would be all the x's that has these two criteria. Okay, but I'm gonna use just very simple way to find the domain of this function, which is what? I have a square root of something, so the domain of it would be x squared minus 9, should be greater than or equal to 0. It's inside the square root, it should be positive. It's not on the denominator of a fraction, so it can be 0 as well. So I'm gonna bring 9 on the other side. I'm gonna take a square root of both sides. Absolute value, square root of x squared is absolute value of x. Square root of 9 is 3. So absolute value of x is greater than or equal to 3. So x is greater than 3, or x should be less than 3. Okay, so this is the domain of this function. Everything that is greater than 3 or actually less than -3. I forgot to put the negative in here. Okay, let me find GOF of x. What is that? It's the same thing, G of f of x. What is f of x? Square root of x is given. Now I need to find g of a square root of x. You see, instead of any x on the function of g, I need to put root x. So root x squared minus 9, this is equal to x minus 9. This is GOF, this one is FOG. So one observation is that FOG of x is not necessarily equal to GOF of x. Okay, so compositions of functions are also very important, and these are the way to find a new function out of two other functions.